The sky turns a bruised violet, and the city of Kusumpura is in a state of panic. Conch shells roar, brass plates clash in rising urgency. Children are being pulled indoors. Priests rush between temples, cupping fragile frames. The moon is being eaten. Slowly, bit by bit, Rahu, the shadow demon, has come. The demon who swallows the moon whole when he is angry. Everyone knows that they have to make noise and pray hard to drive the demon away. Amidst the chaos, a young man is standing completely still in the middle of the courtyard, unaffected. His hand lowers, pointing at the earth where the shadow creeps like a silent tide. His name is Aryabhata, and he already knows something that will take the rest of the world 1,000 years to catch up. He calculated it. He tells the startled priest,
There is no demon. I can tell you when this ends.
it is 499 Common Era, and without any modern instrument, Aryabhata, a 23-year-old man in what is modern-day Patna, has predicted a lunar eclipse precisely. What kind of a world produces people like this? This is the story we are about to tell. You are on India's Golden Age podcast. Subscribe now. To understand Aryabhata, you have to step into his world, and it is not what you expect. He is born in 476 Common Era. The year he is born, at that very moment, the Western Roman Empire is in its final stretch, and India is in the midst of the Gupta Golden Age. The University of Nalanda, close to Kusumpura, is bustling with students. Its multi-storied library is believed to have millions of manuscripts. Scholars arrive from across Asia, drawn by a shared hunger for knowledge. They debate before dawn, relentless. While Rome is decaying, Patna is in the midst of an intellectual revolution. This is the world Aryabhata walks into. He starts reading old texts, and then he starts challenging them. At 20, that takes nerve and genius. Aryabhata names his algorithm Putaka, the pulverizer. The word carries intention. This is dismantling, reducing problems to their core before rebuilding them. The algorithm can be considered as a precursor of the modern day extended Euclidean algorithm. He writes the Aryabhatiya, just 121 Sanskrit verses, small enough to be a pamphlet. You could read that in one sitting, and yet inside that are verses with more raw mathematical firepower than anything produced in the known world for a long time. One of the things in it is pi. He calculates it to 4 decimal places, 3.1416. He knows pi cannot be pinned down perfectly. Aryabhat writes,
This is not the number. This is the closest we can reach. Asanna. Approximate.
Aryabhata wrote this nearly 12 centuries before a Swiss mathematician named Lambert formally proved. Picture yourself on a boat on the Ganga at the sunset. The trees along the shore seem to slip backward as if retreating from you, but they are not moving. You are. From inside the boat, it looks the other way around. Aryabhata looks at the night sky and follows the same thread of thought. What if the stars are not moving? What if we are? Aryabhata writes,
If the stars appear to move west, it is not their journey, it is ours.
The earth is the boat. We are the passengers. How many times must I explain this?
he calculates the length of the sidereal day, 23 hours, 56 minutes, 4.1 seconds. The modern value, 23 hours, 56 minutes, 4.091 seconds. He's off by milliseconds in 499 Common Era with no tools. Nicholas Copernicus, the man the West calls the father of heliocentrism, is born 1,000 years later. Now think of a word from a class 9 trigonometry problem. Sine, as in sine theta, cos theta. Remember that? All of it traces back to the Sanskrit word Aryabhata documented and formalized. Ja, it means cord, like a bold string pulled taut. Arab scholars took ja and wrote it as jiba. Medieval Latin scholars looked at jiba and misread it. They read jaib, which in Arabic means bay or bosom. They translated it sinus, curve. Sinus became sine. Every time a child writes sin x in their exam, they're writing a word that passed through Sanskrit, through Baghdad, through a mistranslation, through medieval Latin, and into their notebook. This is a familiar pattern in the history of ancient science, Indian science, and mathematics. 773 Common Era. Nearly 3 centuries after Aryabhata wrote his book, a delegation from Sindh arrives at the court of Al Mansur in Baghdad, carrying Sanskrit manuscripts. Among them are the works of Aryabhat, Brahmagupta, and other Indian scholars. These texts enter the House of Wisdom, where they are studied and translated. One of the scholars there, Al Khwarizmi, engages deeply with them. He writes Kitab al Hisab al Hindi, meaning the book on Indian calculation, clearly acknowledging the origin. In fact, mathematics itself is often referred to as Hindisat by Arab scholars, the Indian art. Yet when these ideas reach Europe, the narrative shifts. The label changes. Indian mathematics is widely referred to as Arabic, and the original Indian inventors are pushed out of the story. Bakhtiyar Khilji arrives at Nalanda University. 6 centuries of accumulated knowledge, and then they are set ablaze. The fire spreads relentless. They say it burned for months, as if the knowledge itself registered burning. The Kutaka method fades from the northern plains. It travels south. Centuries later, Madhava of Sangama Grama advances the work. He develops infinite series for pi, extending Aryabhat's idea of Vasanna, always approaching, never complete. The idea survives, even when the world around it does not. And then comes the second erasure, cold, calculated. 1835 Common Era. An Englishman, Thomas Babington Macaulay, writes in his Minute on Education.
A single shelf of a good European library is worth the whole native literature of India and Arabia.
We must make the natives English in taste, English in intellect, in culture. That is the only path forward for these people.
The British cut the funding for the Pathshalas, starved the Sanskrit colleges of funds, and 1500 years of living mathematical tradition is officially reclassified as defunct. At the same time, British officials are sending ancient manuscripts to places like the Bodleian Library in Britain. They recognize the value. It is not ignorance, it is a double cross, and it lasted for a century. The children of India grew up learning about Newton, about Galileo, about Copernicus. They forgot the man who felt the earth spin while the Ganga flowed past his feet. 1975, a satellite launches from the Soviet launch site at Kapustin Yar. It weighs 360 kilograms, the weight of an auto rickshaw. It carries instruments meant to read the sky, to measure what once had been calculated and imagined. They name it appropriately Aryabhat. The name carries intent, it signals continuity. India is not borrowing a scientific tradition, it is extending one that already exists. I can almost hear Aryabhat say,
Write it in verse. A verse can travel in the mind of one person, across the sea, across centuries. The palm leaf burns. Memory does not.
You have been on India's Golden Age podcast. Want to experience Gupta Golden Age, in which Aryabhat thrived? Explore my upcoming novel Dhruvadevi, the Queen Who Made Chandragupta. Stay curious, keep questioning, keep challenging, like the 23-year-old from Kusumpura. Jai Hind. Bye for now.